Hey guys, in this lesson we're going to take a look at congruent triangles, and specifically with those congruent triangles we're going to take a look at side-side-side triangle congruence and side-angle-side triangle congruence theorems. So to start off with, either as a reminder or as something new for you, when you're looking at congruent triangles, you're looking at two triangles that have exactly the same three sides and exactly the same three angles between them. Okay, so if you take a look, we have two triangles here, and whenever you're looking, there's pretty much three big things you have to show. You have to show that all three sides are going to be congruent. And the other thing you have to show is that all three sets of the angles between them are going to be congruent as well. So if we're looking, and let's say that this angle is 50, this one's 60, and this one's 70, in order for those two triangles to be congruent, they have to have congruent angles that match up together. So like look at these two triangles. If this one's 50, that one's got to be 50. If this one's 60, this one also has to be 60. And if that one's 70, this one also has to be 70. So you've got to show all three angles are congruent. So if we make those congruency statements, we've got angle A is going to be congruent to, and remember congruent is the geometry word for equals. So A is going to be congruent to angle D, and then angle B is going to be congruent to angle E, and angle C is going to be congruent to angle F. So that's half of it. We have to show three sides and three angles. So we started with the angles first. So now we've got to show that the corresponding sides are also going to be congruent. So let's say this side is 3, this side is 4, and this one is 6. If they tell you these two triangles are congruent, then that means side AC has to be congruent to side, and it's got to be the one that matches up over here with it. And since the 3 is across from the 70, the 3 has to go across from the 70 over there. So AC is going to be congruent to DF. Looking at the next one is 4. 4 is AB, is going to be congruent to, it's across from the 50, so that one right there. So this one is going to be 4 as well. And then looking at the last one, the last side that we have to work with right here is CB. And CB is going to have to be congruent to FE or EF. No, but it's got to be FE because order matters whenever you're working with congruence, just like it did with similarity. So just to double check and make sure we have all the corresponding parts matched up, A matches up with AC, matches up with DF, AB matches up with DE, and CB matches up with FE. So there's all three of our sides shown to be congruent. So with doing congruent triangles, if you can show those three sides and you can show the three angles, then you can make a triangle congruency statement. And when you're looking at a triangle congruency statement, you're saying this triangle is congruent to this one, and whenever you name them, you have to match up the matching parts to each other. So we're looking at triangle. The first one's easy to do. You can just go whatever order you want to. ABC is going to be congruent to, now we started with A first. A is 60 degrees, So we're going to go the angle that's 60 degrees there, which is D. So triangle D. And then we went to the angle that is 70 degrees, which is B. So we'll go over to the 70-degree angle here, which is E. And then we ended with we ended with C. So C is our 50-degree angle and F is our 50-degree angle there. So there's our triangle congruency statement for those two triangles. But whenever you work with things and you do things in life, you're not always going to get all of, and it's actually 12 pieces, all 12 pieces of information that you need in order to be able to show that triangles are congruent. And that's where they came up with these triangle congruent theorems. And they said if you had these they were able to show and prove that if you had these certain sides, you had enough information to be able to say that the two triangles are for sure going to be congruent to each other. So there's several of them. The first, we're going to look at two of them today. The first two that we're looking at is, first one is the side congruence theorem. And what this one says, if you have three sides of one triangle, and those three sides are congruent to corresponding or matching sides of another triangle, then you can say that the triangles are congruent. And for a short explanation as to why, without getting into doing a big long proof, you remember whenever we did the lessons showing there's a direct relationship between the measure of an angle and its opposite side? That's what they're using to help say that, well, if you've got three sides and the three sides are equal, their opposite angles also have to be equal as well. So that's how they're able to cover and use side. So if we're looking at this one, so three sides congruent of one triangle congruent to the second one. Let's say AC was the same length as DF, and then CB is congruent to FE. And they would have to tell you this somehow in the picture, or you would have to be able to solve for the values to show that they're same. Either way, you have to show three sides are congruent. That's what you have to show. Whereas up here, you had to show the three sides are congruent and the two angles are congruent. With the side congruence theorem, and you can just abbreviate it side congruency like that, all you have to do is show the three sides. So looking at this one, they tell us that that side is congruent to that side. And this is part of what showing your work for these types of problems to be. You would do the math, or you would find that AC is congruent to DF, and you would write that down. And then you would do CB and FE. So CB is congruent to FE. And then you've got AB here is congruent to DE there. So AB is going to be congruent to DE. And notice I'm still being very careful about which letters go where, because when you're working with congruency, the parts that match up together matter. So once you're able to show all three sides are going to be congruent, you're able to write your triangle congruency statement. So when you write these statements, for the most part, whenever you're picking the letters for the first triangle, the order honestly doesn't matter. So we could go A, C, B for this one. I know there is the exact same order and the exact same parts are shown to be congruent in this one as that one, but this would be another way to write the congruency statement for this one too. So with these, I'm going to just try and show you different ways to write the congruency statement, because when you're doing these multiple choice tests, just because you find one way and that one way that you found isn't in the multiple choice answer options, that doesn't necessarily mean you've done the problem wrong. It just means you may need to rearrange some of the letters you have to see if you can't make them match what the multiple choice problem is. But you've got to be very careful. If you've got A here, it's got to match up with D. no matter where it is, whether it's first, second, or third, if wherever A is first, second, or third, D has to be in that same exact spot, first, second, or third. So there's A to D, and then we went to C, so we go to F. So it goes D, F, E for that congruency statement. Okay. Looking at these, the next one is an included angle, and I know we've probably talked about this before, but just as a reminder, the included angle is an angle that is between two sides in a triangle. So technically, all of the angles are considered included, but if you're given information for, let's say, side AC and AB, so if they tell you you've got AC and AB, the included angle between those two sides is going to be angle A. That's going to be the included angle. If you have trouble picking out included angles and you look at the name of the sides, what letter shows up both times in those? A does. So that's one way to try and help you out. Okay. The reason why it's so important to be able to find those is when you're doing the side angle side congruence theorem. And this one says if you've got two sides and the included angle of one triangle, and you can show they're congruent to the corresponding sides and the same included angle of a second triangle, you're going to be able to say that the two triangles are congruent. So if we know that side and that side are the same, and we know, let's go this side and that side are the same, what would the included angle between those two sides be? What about for this one? Hopefully you're looking at angle C, and then for this one, hopefully you're looking at angle F. So if two sides, so what you have to show with this one, whereas this one you really only had to show one big category of things, this one you have to show two. First thing you have to show is you've got to show two sides are congruent. And the second thing you have to show is the included angle. And notice I'm not just putting angle like I did up here. With this one, I just said 3 angles. With this one, it really matters which angle you use, because if you don't use that one, it's not, the theorem doesn't work. So included angle. So you've got to show two sides are congruent and the included angles are congruent. So if we're looking, here they give us side AC and DF. So they tell us AC is congruent to DF, and the way they tell us is they put those little tick marks on there. And then let's do CB congruent to FE. And then looking at the included angle. Angle C, and the way we know they're congruent, just like we knew the sides are congruent, they use the tick marks. With the angles, they're going to use those little arc marks. So angle C is going to be congruent to angle F. So since we were able to show that two sides are congruent and their included angle is congruent, we can say that the two triangles are congruent. So triangle, let's see, both of those we started with an A, so let's start with something else to write a different congruency statement. So let's go with triangle CAB. Triangle CAB is going to be congruent, so we start with C. C matches up with F. Triangle F, and then A matches up with D, and then B matches up with E. And the way, so there's our triangle congruency statement for this way. And the way they, just a short reason as to why this side angle side congruency theorem, they're still pulling on the idea of the relationship between the sides and their angles. And if we know these two sides are congruent and we know these two angles are congruent, we also know this side is congruent. So that's kind of going back to that side congruency theorem and the relationship between those angles. So how does this stuff work? Looking at the first example, we're starting with side, side, side congruence. So in this question, they want to know which two triangles are congruent by the side, side, side theorem. Complete the congruence statement. So when you're looking at these types where they give you tick marks, you have to match up the tick marks. So looking at this one has one tick mark, and when you're in side, 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 you've got to have all three sides congruent. So looking at this one has one tick mark, that one has 3, that one has 3. So if we're looking for a triangle that's congruent to this one, we've got to have 1, 3, oh, that one has 4. So we would have to find a triangle that has one tick mark on one side, 3 tick marks on another one, and then 4 tick marks on the other. So looking, this one has 2, 3, 4. So we know automatically those two could not be congruent because this triangle in the middle does not have one tick mark like this one on the right does. So then checking over here for a 1, 3, 4, 1, 3, 4, it doesn't match up. So we know those two can't be congruent. So now we're looking at our last option that we have. This one goes 2, 3, 4, 2, 3, 4. So we're able to show FG matches up with TV and VU matches up with EG and TU matches up with FE. Whenever I do these types of problems, whenever I can, I try really hard to use different colors because it really brings out and shows you the different sides really easily, and you're not looking at the tick marks and trying to remember how many tick marks there are. You can just match color to color. So now they want us to complete the congruence statement between the two triangles that are congruent. So I've got triangle, and I'm just going to go in alphabetical order. Just being a math person, I like putting stuff in order. So triangle EFG that's how I'm going to decide how to name the first triangle. Now for the second triangle, I'm going to use the congruent parts. So we're looking at, oh, and I forgot to write those congruency statements. So to show you what that would look like to work everything out. We would have FG is congruent to, so I started up at the top with the green and went down to the blue. There's the green there, so there's TV. And then let's go GE is congruent to, so with G I started up by the purple and went down to the green, so you're starting to be able to see how much those colors can help. So going down to the green, so then purple to green is VU, and then going, let's go blue, purple, so that'll be EF is going to be congruent to, starting down here with the intersection where it's blue, to U and up to T. Okay, so there's where we've shown that all three of those sides are congruent. So triangle EFG is going to be congruent to triangle. Angle E is next to the blue and the green, or the one with the 3 and the 4. So we go with the 3 and the 4 there. So it's going to be U, and then we went F next. So that means we do T next, and then G matches up with V. Whenever you're putting these answers in or writing these answers down, it doesn't matter which letter you start with when you start the initial one over here. They'll take whatever you start with, as long as the corresponding parts over here match up to the corresponding parts in the initial one that you do. Okay. Another type of problem that they could have you do with these is they could have you write a proof. And you've got to take you've done these before, you've got to take the information that they give you to work with and figure out how to get where you're going. So looking at this one, T is the midpoint of SU, TV is congruent to UW, and TW is congruent to SV. So this is our given information to work with. That's what we're given to work with. They want us to complete the proof that, so this is what they want us to show, so this is our proof. So that's what needs to go down here in this bottom box. So we've got triangle STV is congruent to triangle TUW. So there's our final answer that we're going to have. So we've got to start with the stuff that we have in the beginning. We've got T is the midpoint of SU, They've got that there. T is the midpoint of SU. So this statement here is exactly the same statement that was given in our given. So this is going to be our given. So then next we're looking at TV. So looking at here what's going on in the picture. T is the midpoint of SU. T is the midpoint for that segment right there. And then the next part we're looking at is TV is congruent to UW. So if we look up here in the information they gave us to work with, it's right there. But I'm going to make sure to go ahead and mark it in the picture. So TV, so that one right there, is going to be congruent to UW. So that side right there. And the way we know that that statement is true is that was given to us in our given. So far they've given us to work with two congruent sides. And usually whenever I do these types of proofs, I'll go through and label whenever they tell me either sides are congruent or angles are congruent. I'll go through and mark that this is the first set of sides that they're given. And then that way whenever I'm looking back through and trying to figure out what congruency statement it's, what it is, whether it's side, angle, side, or side, 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 it'll be really easy for me to try and see and figure out which one it's going to be instead of trying to remember which ones have I seen and which ones I haven't. So then looking next, they give us TW is congruent to SV, and there's the TW and SV up there. We find it down here. TW is congruent to SV, so show those with tick marks. So again, this is another side that they've given us to work with. So still at this point, it could either be the two we were given to work with, side, 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 or side, angle, side. And looking at the last one, oh yeah, this is given, is going to be what helps us to determine what we're working with. So then we're looking at ST is congruent to TU. So if we look up here, they don't word for word tell us that ST is congruent to TU. So now I'm going to come down and look in the picture. Well, the information that we've been given to work with, and I'm actually going to use a different color because I didn't realize it was going to be the same. We'll make it orange. That'll look nice. The only piece of information we were given to work with this is T is the midpoint of SU. Well, think about, what does it mean that T is the midpoint of SU? Well, if it's in the midpoint, it's exactly in the middle. So it cuts that whole entire segment in half. And if it cuts it in half, that means this part right here, ST, is going to be congruent to TU. And we use this information up here. T is the midpoint. We used what it meant for it to be a midpoint. And anytime you're using and doing something and saying, well, that's just what that means, that's going to be definition of midpoint. Okay, so this will give us a third side to work with. So here we've got three sides. So this is going to be side, side, side congruency. It was either going to be side, side, side congruency or side, angle, side congruency for this section. So out of the two, given three sides that we're given to work with. So looking at the next two, another way they could give you this side, side, side congruence theorem to be working with is they could give you triangles in a coordinate plane, because you can use that wonderful distance formula to find the distance between all the points, and then using the information from those distances, be able to say whether or not you have congruent triangles. So when you're looking at these examples, if you're given lines that are either vertical or horizontal, take advantage of those opportunities. Don't do the distance formula between TU. There's no point. You can just sit and count the distance between those. So you're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9. The distance between T and U is 9. The distance between US is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The distance between those two is 10. You're kind of going to have to do the distance formula between T and S. So if we do that one, T is -7, 0, and then S is going to be 3, negative 9. So the distance is going to be equal to x1 minus x2 squared plus y1 minus y2 squared. So the distance is going to be equal to the square root of 3 minus a negative 7 squared plus negative 9 minus 0 squared. So distance is going to be equal to the square root of 3 minus a negative 7 is going to be 10 squared plus negative 9 squared. So 10 squared is going to be 100 plus negative 9 squared. Remember, if you put that in your calculator, to put the parentheses around the negative 9 to make sure you get that positive 81. So we're looking at square root of 181, and that's our distance from T to S. I'm going to write T to S for the rest of them. That way we can tell the difference between which two we have. So then look in here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's a 10 there. Now don't just assume that because there was a 10 here and a 9 there, that means those two aren't congruent, because you still have this side to go right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's a 9 there. So there's a 10, there's a 10, there's a 9, there's a 9. So as long as the distance from J to I is going to be the same, and then we're going to have congruent if they're different. So we're down to these two lines are the determining factors. So if we're looking, the distance between Ji is going to be equal to the square root of, and this point is 1, negative 3, and this point is 10, 7. So 10 minus 1 squared plus 10 minus 1, 7 minus a negative 3. So Ji is going to be equal to the square root of 9 squared plus 7 minus a negative 3 is 10 squared. 81 plus 100. Square root of 181 is what we end up with for Ji. And those two are the exact same number. So yes, those two triangles are going to be congruent. And if we were going to write congruency statement, so this is the square root of 181. You would say that triangle TUS is going to be congruent to, now looking at angle T. Angle T is between 9 and 181. So the angle that matches up with angle T is going to be between 9 and 181. So that included angle we're looking for, that's going to be J. And then looking at U, it's that right angle. So the right angle there is K. And then S is the last one. So, and it's between 10 and 181, so that makes it BI. If you end up with any duplicate letters, that's one way to know that you've made a mistake. Also, the letters in one triangle cannot match up with the letters in another triangle. Alrighty, so looking at this next example I've got for you, 1, 2, 3, 4, 5, 6, 7, 8, 9. They want to know if those two triangles are congruent. So if we're going to show those two triangles are congruent on a coordinate plane, we've got to try and use that side congruence theorem. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that one's 9 and this one's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so just to double check and make sure I didn't miscount. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So those two sides are 9. This one is 10. So automatically we know that these two sides cannot be congruent, or these two triangles cannot be congruent because it doesn't have congruent sides. So this one is a no. All right, so last couple examples, we're looking at the side angle side congruence. Which two triangles are congruent by side angle side theorem? And you got to watch. This example does not do this, but you will get some examples where they will put that arc mark here at angle W and angle J, and they will be the same, but it's not going to be side angle side congruency, because remember, if you take a look at the definition, it says the included angle. Included angle. And remember that included angle I'm going to make it blue to match the blue that I did in the picture. The included angle is going to be the one between those two sides. So they will give you problems that look like they work with angles being congruent here, but they're not going to actually work. You have to make sure that the angle is between those two sides. So that being said, looking at all three of those triangles, the angle is included between two sides. So our worry isn't so much about the angles and where they are and whether they're included or not. Our worry now is the sides and figuring out whether or not the sides are the same. So looking here, this side has 3, this side has 3, this side has 3. So it's safe. So we could say that all three of those sides and each of those triangles are going to be congruent between each other. So now it's a matter of, well, that one has 2, that one has 2, that one has 1. So that means these two triangles are going to be congruent using our side angle side theorem. And remember, using that theorem that says we have to show that, first thing we have to show, two sides are congruent, and we have to show the included angle is congruent. So looking at the two sides that are congruent, we've got those two. So we've got xy is congruent to ik, and yw is going to be congruent to kj. And then looking at our included angles, got that angle and that angle. So we've got angle y is going to be congruent to angle k. So if we write our congruency statement, we've got xyw is going to be similar to, so I started with x, which is at the end of the purple, so the end of the purple is I. And then I went to y next, the included angle, so do the included angle k. And then down to the end of the pink, which is w, and j in the other triangle. So there's our congruent statement. And then they could also have you do the proofs. So remember with the proofs to be using that list of good reasons that we did back in chapter, I believe it was chapter 2. And that'll come in really handy for these. And it'll give you the list of everything. The only thing that's new added so far is to do the side congruency and the side angle side congruency. And I'll put that on for you in the next video. But looking at this one, we've got, first thing they give us is TUW is equilateral. So where did they tell us if they did it all, where TUW is equilateral? And if you look, there it is there, and there it is there. So this is given in our information that we have to work with. So this is a given. The next thing that they give us is that UV is congruent to TX. And I check up here first, and it is there. So that tells us that UV congruent to TX is a given. So if I start putting some of this stuff in the picture before I get too much to work with, that tells us that TUW is equilateral. So that's that triangle right there. And if you remember, equilateral triangle means all those sides are congruent. So keep that in mind. That might come in handy later. And then they tell us that UV, so this one right here, is congruent to TX. And the reason why I didn't mark these here is because it just tells you that the triangle is equilateral. You have to use the definition of equilateral to say that they're the same if we're going to do that. So then next we're looking at angle WTX. So WTX, so this angle right here is going to be congruent to VUW, that angle right there. So those two angles are the same. And checking up here to see if they told us that in our given information, they sure did. It's right there. So this is another given. And then looking at that next statement, they tell us that TW is going to be congruent to UW. So how did we know that TW, if you look up here, it's not up there. So how did we know that TW is equal to UW again? These are part of that equilateral triangle, and we used what it meant to have an equilateral triangle to say those two are congruent. So using what something means is the definition of whatever word you use, so equilateral. And then the last step. Well, let's look and see what they gave us to work with. To start off with, they gave us two sides that are congruent. So that's our first set of sides that are congruent. Next, they gave us an angle. So I've got one angle, one set of angles that are congruent. And then last, we've got a second set of sides to be working with. So it looks like it's going to be side angle side congruency. But the big thing we have to check to make sure, we have to check and make sure that that angle is included between the two sides they have given us to work with. And in this triangle, they gave us UV and UW. Those are our two sides. So that makes that angle right there be included. So that triangle's good. And then checking this triangle, we're given this side to work with there and that side to work with there. So there's our included angle there. So we're good with having the included angles. So now we can say for sure that triangle TWX is going to be similar to triangle UWV by side angle side congruency. So there's you some examples with side angle side congruence, and there's you couple with your side congruence. This is a whole individual exercise by itself, and they didn't have one for side angle side, and you really can't have examples for these for anything to do with angles, because unless they give you a protractor, there's no way to measure those angles in a coordinate plane. I mean, I guess you could get into slope, but that gets kind of cumbersome. So at least for the exercises that I have right now, there's not going to be any practice problems for those. So there's you some pretty good examples for both. Sorry, I had these down here, looking at the angles there. You would have to have a protractor in order to be able to measure those. So, yeah. So there's just some pretty good examples of how you can find congruent triangles using the side congruence theorem and the side angle side congruence theorem. If you have any questions, be sure to write them down and ask when you get to class.